Now we will see the 18th problem. The question is, for what value of lambda is the function defined by f of x is equal to lambda into x square minus 2x if x is less than or equal to 0, or 4x plus 1 if x is greater than 0. When, for what values of lambda, when you substitute here, this function will become a continuous function at x is equal to 0. Okay. So what about continuity at x is equal to 1 is an extended question. So first let's check what should be the value of lambda for it to be continuous at x is equal to 0. So the solution here is, now when you take the left limit at x is equal to 0, so left limit is limit x tends to 0 minus f of x. So this will be limit x tends to 0 minus, what is the limit, what is the function value we are supposed to take? So the function that we are supposed to take is lambda into x square minus 2x. So this will be limit h tends to 0 lambda into 0 minus h the whole square minus 2 into 0 minus h. Okay. So this will be limit h tends to 0 lambda into 0 minus h the whole square is h square minus of minus 2h is plus 2h. Now when you substitute 0 here, this value will be equal to 0. Similarly, what about the right limit? So when you take the right limit, limit x tends to 0 plus, it is going to be 4x plus 1, right? So it is limit h tends to 0, 4 into, in the place of x we can write it as 0 plus h plus 1. So 4 into 0 plus h1 plus 1 is limit h tends to 0, 4h plus 1, when you substitute the value it will be 1. Since you observe the left limit is going to be 0 and the right limit is going to be 1, and if you observe this value of the left limit is independent of the value of lambda. So from this what we can conclude is, there is going to be no value of lambda for which this function is going to be continuous, because whatever is the value of lambda that you are going to substitute here, the function that is getting multiplied with this lambda is always going to make this whole expression a 0 on the left hand side. Since left limit can never be equal to the right limit for whatsoever is the value of lambda, the answer to this is, there is no value of lambda, there is no value of lambda for which function is continuous. Okay. So first copy this. So once you finish this, now we will also check what about the continuity at x is equal to 1. Now we will try to check the continuity at x is equal to 1. If that should happen, what should be the value of lambda? See, there is a simpler case. If you take the number line, 0 is going to be here and 1 is here. So when the value of x is greater than 0, from here itself the function that is getting defined is 4x plus 1. But anything on the left hand side is going to be lambda into x square minus 2x, right? So it is going to be like this. Since 1 is a point here, at 1, what is the function that is defined? It is 4x plus 1. So 4x plus 1 being a polynomial function which is defined at x is equal to 1, we can say, since a polynomial function is continuous throughout its domain, for any value of lambda, because at x is equal to 1, lambda is not at all involved, for any value of lambda, the function is going to be continuous at x is equal to 1. So this is all about the continuity of the function at x is equal to 0 and x is equal to 1.